Hello, good day, everybody. This is Jimo coming to you once again on ScoreBooster project. So today, as I have reading on the board here, I'm gonna continue with calculus and specifically integration. And today is gonna be the last topic under calculus, and the subtopic we shall be looking at is area under the curve. The applications of integration in all human endeavors, be it science, engineering, medicine, commerce, business, economics, just name it. Graphs or curves are used to explain or present results of findings. For example, we all familiar with this kind of graph, XY graph, where you have something like this. This can be a variable, let's say population, and this can be time. It can be a lot of things. And this graph, we have an equation, let's say f of x. To make some senses out of this kind of graph, sometimes we want to find the area under the curve. One rough way of doing this is to draw out varieties of shapes that you are familiar with. For example, we can draw out rectangle, we can draw out trapezium, triangle, and so on. Find the area of these shapes and add them together. For instance, assuming that I want to find the area of this, let me just redraw this one to make it clearer. So if I have something like this, I have y is equals to f of x, and this is my origin, y0, and I have these points that I want to find the area. Let me call this one x1, x2, and this is y1 and 2. So for me to be able to find this area, I can just take this one as approximately as a trapezium. And usually to find the area of a trapezium, we say area is equals to half sum of the parallel sides times height. So 1/2 sum of the parallel side. This is the parallel side, these are the parallel sides. So sum of this one from here to here is y1 minus y0, plus from here to here is y2 minus y0, then times the height. The height is from here to here. That will be the height, and that will be s2 minus x1. If I want to compress this, it's gonna be summation of delta y and times delta x. So by so doing, we see that to find the area, all we need to do is to multiply y, which is f of x, by the derivative of x. This is just an explanation, and to see how we got to using the formula I'm going to show us later. So rather than dividing the area under this curve into various shapes, one easy way of doing it is to use integration. So let us see how to do that. So let's assume that we have this and we want to find the area, and this curve is f of x, y is equals to f of x, and we have this point to be a and we have this to be b. So this is y and this is x axis. So the area under the region, this region that I've shaded, that lies between the graph of y, that is this one, and above the x-axis, this is x-axis, from x is equals to a and x is equals to b, is given by a is equals to integral of a b f of x dx. So this is our equation 1. So the area under this curve is given by integral of a to b f of x dx. There are some conditions I think it's good for me to mention it. F should be continuous on a closed and bounded interval a and b. The second one, f should be non-negative on AB. So some of the conditions, and for your information, I need to reiterate here that in JAMB you need not to worry, because all the questions that will be given to you will satisfy these conditions. So you don't need to check maybe this condition hold or not. So in essence, what you should be concerned about is how to be able to put the formula in your brain. Now let's look at some example and see how this formula is applied example 1. Example 1. This is coming from UME 1995, question 41. I must add here that from my observation, this question is not too common in recent JAM question. However, it is part of the syllabus, so you should just make sure you get to know them. So is find the area bounded by the curve y is equals to 3x squared minus 2x plus 1. The ordinates x is equals to 1 and x is equals to 3, and the x axis. So our score booster solution. So what's as usual, what I always advise is that for amateur in mathematics, the first thing to do is to write down the formula. That is, a is equals to integral of a b f of x dx. By writing this formula, then you begin to think, what are the things that you need as inputs to be able to use this formula to solve your question. So the first thing we should look out for is now, what is our a? Our a is 1. What is our b? Our b is 3. And what is f of x? F of x is y, and it was given as 3x squared minus 2x plus 1. So the next thing is just to substitute all these inputs and get your answer. So a is equals to integral from 1 to 3 of 3x squared minus 2x plus 1, then dx. So what next? You integrate. Integration 3s cubed over 3 minus 2s squared over 2 plus 1 x1 over 1. Okay, and that will be 0. That will be 1, 2, 3. So this 3 cancels 3, 2 cancels 2. Sometimes, especially when I was preparing for JAM, once I'm doing some workings and I discover that it's getting too long, quickly I get to know that I'm not getting it right. Because JAM will always give you expression that you can solve within few seconds, not the ones that will take you few minutes to solve. As you can see now, this expression becomes very easy, because at the end we're gonna have something like this. We're gonna have s cubed minus s squared plus x 1, 3. So if you simplify this one, or before simplification, just substitute for the limits. So we're gonna have 3 raised to power 3 minus 3 raised to power 2 plus 3 minus 1 raised to power 3 minus 1 raised to power 2 plus 1. So if you simplify this, you're gonna get 22 square units. And this is the answer. As simple as that, right? Let's take another example. It's a straightforward thing, I guess. Oh, I'm sure. Not even guessing. I'm sure it's straightforward. So example 2. This is also a past question in 1999. Question 33. Find the area bounded by the curve y is equals to x into 2 minus x. The x-axis, x is equals to 0 and x is equals to 2. Score booster solution goes thus. As usual, we write out the formula, okay, and from the question, a is equals to 0, our b is equals to 2, okay, and the f of x we are given is equals to y is equals to x into 2x into 2 minus x. So therefore our a is equals to 0 to 2, as we are integrating, and it's gonna be x into 2 minus x dx. And what else? You open this bracket, you're gonna have 2s minus s squared dx. Now if I integrate, I'm gonna have 2s squared over 2 minus s cubed over 3 is 0 to 2. So if you substitute this, you're gonna have 2 squared minus 1 over 3 times 2 raised to power 3 minus 0 squared, right, minus 1 over 3 times 0 cube. So the whole of this is 0. So you only need to deal with this. So this will be 8 over 3. 2 raised to power 3 is 8. So, and you have this 3, 8 over 3. In JAMP, you don't have time to start finding LCM and some other thing. So just make 4 to be equals to 12 over 3. Okay, and then you can subtract 8 from 12. 8 minus 12 will give you 4, then over 3. So your answer is 1 number 1 over 3. Okay, 1 number 1 over 3 square units. With these two examples, I believe you must have grabbed the essential tool that you need to destroy any question that come under this topic. So I'm going to end this lecture by giving you some exercises to work with. First one is find the area of the region that is bounded by the curve. Y is equals to square root of x. The line x is equals to 1 and the x axis. So I'll give you a hint. A is equals to 0. So your answer will be 2/3 square units. Number 2, find the area under the curve y is equals to 4 plus 3s squared. The x axis, s is equals to 0 and x is equals to 1, and this is 4 square units. Number 3, find the area under the curve y is equals to 2 minus s squared. The x axis, x is equals to 0, x is equals to 2, and your answer should be 4/3 square units. To God be the glory. This is the last video under calculus. Calculus is a very large topic in JAMB, and this is the 13th video on calculus. So previously I have done 12 videos. So with these 13 videos, you have a complete package for you to scale through any question that comes under calculus in JAMB. I'm sure if you can take your time to take the video one after the other, listen to them, solve the exercise that I provide at the end of the video, I'm sure you will be well grounded in tackling any questions that comes in calculus in JAMB. You can also shoot me an email from the contact I've provided. You can also go to the ScoreBooster project website, www.scoreboosterproject.com. WhatsApp, our number is there. Be it through comments. After watching our video, there is a space where you can put your comments. You can contact us from there. Also on our website, there is a form you can fill. Just fill it, put your comments. If you have any question, just put it and submit. We get it and we respond back to you as soon as possible. So we encourage you to subscribe to our YouTube channel, ScoreBooster-Mathematics. We also encourage you to invite people, tell them about this project, and let others also benefit from it.